Welcome to the third video in our Class 17 series of lecture videos. We're going to try to answer the question, how do we make alcohols? And we're answering this question from the perspective of chemists. I know my biology colleagues would prefer to exploit yeast to ferment things, but we in chemistry prefer a very straightforward sort of physical approach of either oxidation or reduction of other organic molecules. So what is oxidation? It's loss of 2 electrons. Reduction could be described as gain of 2 electrons. We can also describe these processes a little different way. So we'll go ahead and do that. Oxidation is when an electronegative atom, such as a halogen or an oxygen atom, is added to a molecule, or alternatively, when hydrogen is lost. So here we have toluene, methylbenzene. We add 1 oxygen atom from our diatomic oxygen. Maybe we'll insert that between a carbon-hydrogen bond and we'll make benzyl alcohol. Well, we just oxidized that toluene. Another way of looking at oxidation is here we have cyclohexadiene, in fact 1,3-cyclohexadiene. We could throw this in with a palladium catalyst and heat it a bit and we would get benzene and hydrogen gas coming off. So we lost hydrogen, two atoms of hydrogen, and so we call that an oxidation of our cyclohexadiene. How about this cyclohexanol? Well, we have 2 hydrogens here. We throw in a catalyst to oxidize this, and lo and behold, now our carbon has a double bond to oxygen, so there's no hydrogen either on the carbonyl carbon, that is the carbon with the double bond to oxygen, nor is there a hydrogen on the oxygen. So we lost our 2 hydrogen atoms and 2 electrons. So that is an oxidation of our cyclohexyl alcohol, our cyclohexanol. So we could also think, instead of forming a ketone, we could oxidize a primary alcohol. So strip one of those hydrogens off of that carbon and the hydrogen off of the alcohol, and we would make what is known as an aldehyde. So reduction, that's removal of halogens or oxygen from a molecule, or the addition of hydrogen, 2 hydrogen atoms and their electrons. So here we have trans-2-butene. We're adding hydrogen. Maybe we've got a catalyst to help us do this. We make butane. Here's methoxybenzyl ether. We add hydrogen and a catalyst, probably palladium or platinum again, and we make our toluene and methanol. And here's acetone. We add hydrogen and a catalyst, and lo and behold, we make isopropyl alcohol. There is 1 hydrogen bonded to this carbon that is not explicitly drawn. I know that everyone knows that because everyone is familiar with bond line at this point. So we're going to make alcohols from the reduction of carbonyl compounds. That is, compounds that contain these groups of carbon with a double bond to oxygen. We know that that carbon is electropositive because oxygen is more electronegative. So we can assign a delta plus to that carbon and a delta minus to the oxygen. You could also draw a minor resonance form where there is a formal positive charge associated with that carbon and a formal negative charge associated with the oxygen. It would be unusual to draw a resonance form where you put that double bond onto the carbon and put a formal positive on oxygen and a formal negative on the carbon, because that kind of goes against our ideas of electronegativity. So how would we in principle reduce a carbonyl group? Well, we would need to use something called a hydride. So that's like a hydrogen atom that owns 2 electrons, that is negatively tuned. So here we have it with the formal negative charge because we know hydrogen has one proton in its nucleus. It should only have one electron to be neutral. If you have two things around hydrogen, you've got to add that formal minus charge. And we'll use that pair of electrons to form a bond to our carbonyl carbon. If we do that, we have to break a bond, and it will be the double bond. We'll go ahead and push that up onto oxygen. And so there we have it. In a second step for this reduction, we've got to add some sort of acid, so a positively tuned hydrogen, to neutralize our alkoxide base that we formed. And there we have it. We reduced that carbonyl by adding hydrogen and 2 electrons. What kind of reagents give us hydrides? Well, that would be things like sodium boryl hydride. The hydrogens in boryl hydride are negatively tuned. Hydrogen actually has a higher electronegativity than boron. And so it's a very mild reducing agent. We'll talk about some other reducing agents that are similar to sodium boryl hydride and perhaps a little stronger. So that will be in future videos. So this is the end of our third lecture video in this class time.